And now we'll talk about sums of finite arithmetic series. That just means that the series will have a beginning and an end if it's finite. Infinite means it would go on forever. So the first formula is given here. The second is given here. The difference is the first formula, you don't know the common difference, but you do know the first and last terms. And the second one, you do know the common difference, but you don't know necessarily the last term. So those are the two formulas we can use. All right, so keep these in the back of your mind. It'll be n over 2 for both of them, and then here it'd be the first one plus the last term. They're multiplying to n times 2. This one, you multiply 2 times the first term plus n minus 1 times the difference. Okay, so here, this time I notice right off the bat, I know the first term. I know that a sub 1 is this, and I know my last term. It's there. Now, what I don't necessarily know is how many terms are here. I can tell that it's increasing by 5 every time. So, going back over here, I know what my difference is, and I know my first term, but I don't necessarily know how many terms are here. So if I picked a formula, I'd probably choose this one because I don't know how many terms are there. All right? First I probably could just find out how many terms are there just by using the old explicit formula. Remember this one from earlier is n minus 1 times d. This would probably be the quickest way just to find out how many terms are actually there. So we know our first term is negative 3. Excuse me. That means last term. It's 157. Negative 3 is our first term. We don't know how many terms are there, but we do know it's increasing by 5 every time. So I go to simplify, and I'm going to distribute this first. And I'll also add 3 on this step. So I'm doing two things here. So I'll say 160 equals 5n minus 5. Now I add the 5 over. We get 165 equals 5n. And finally, I want to divide this by 5. And so I should get 33 equals n. Now I know there's 33 terms. And so you could actually replace it as a sub 33. So now if I want to use the first formula, I could say the sum of the first 33 terms is equal to n over 2, which in this case is 33 over 2, times the first term, negative 3, plus the last term, which is 157. So here I get 154. I'm going to divide, let's just use a calculator. That's going to be a huge number. So we'll come over here, calculator, and so we have 33 over 2, and that's going to multiply times, and I'll just, parentheses, negative 3 plus 157 to make sure I don't make any other errors. And I need a 2 right there. Press enter. 2,541. So the sum of the first 33 terms is 2,541. And that would be my answer here. Okay. Now, if we wanted to use something we learned last class, so that's using the calculator, what we would say is this is the same thing as saying the sum from the first term, n equals 1, to 33 terms, and you would type in the explicit formula, which we know the explicit formula, you would type in the right side over here. The first term is negative 3 plus, you'd say n minus 1 times the difference, which was 5. And all this is in one big parenthesis there. And so if you type this in, the calculator should give us the same thing. So let's check it again just to make sure we remember how to do this. It's the button next to 9. You press that, you'll see sum there. And so you say n is equal to 1, and we're adding up 33 of these terms. And the way to find any term is you would take the first term, which was negative 3, and you add n minus 1, and you multiply that times 5. Press enter. we got the same amount. So we did, in fact, do this correctly. Let's try again. So it says find the 17th partial sum. So again, our way to write that is capital S 17 of this arithmetic series. So let's see what's happening over here. We know our first term. We do not know our last term. We could find what's happening every time. It looks like this has been subtracted by 22 units. Let's try again. Is that subtracting 22? Yes, it is. So our D equals negative 22. So we have our first term and we have our difference. If you go back to the formulas, you'll see that if you have a difference in your first term, you probably want to use this formula. So let's copy that over here. We know that S of n equals n over 2 times, they use that bracket, 2 times the first term, and then remember over here they say n minus 1 times d, a lot like the explicit formula. And so now, let's see if we can solve for this starting from here. We can. We know how many terms there are. There are 17 terms. Put this over 2, and we're going to multiply this times 2 times our first term, which is 53. It's ugly, 53. Let me try that again. 53. And then we're going to add that to n minus 1, which is 17 minus 1 times the difference of negative 22. And so let's plug all that in the calculator and see what we come up with. So we would say, let me clear all this, n over 2, which is 17 over 2. And we're going to multiply this times 2 times the first term, which I'm forgetting again, it was 53, plus, the formula said n minus 1, times the difference, which was negative 22. And I'm going to put this in parentheses just to make sure, because we're multiplying there, that I don't mess up. I'm going to press enter. I'm sorry, I'm not supposed to hit n there. Let me try this again. We know that n is 17. And it says the sum is negative 2,091. So here we could say that S is 17 is negative 2,091. And now I have one more here, just so you can review how to use this. Now that we want to say this is the partial sum of the first 32 terms because we're not starting at 1. We can easily find this in the calculator. We go to the button next to 9, click it there, n starts at 10. And we're going to keep adding the sums from term 10 to term 32. And the equation was n plus 6. Put that in the calculator, press enter. There's our answer there, 621. So that's how you accomplish these. And I got this one now for you to go ahead and try yourself.